Good day, everyone. So, today we shall be considering another aspect of basic technology, and that is metal work. So, under this topic, we'll be considering tools for marking out and for measuring. Okay, these tools are very essential for precision fabrication. You need to master these instruments so that you can accurately measure your metal and mark out parts that you need to measure. All right, so can we dive into this topic? So let's consider first of all what these tools are. Today, basically, we're looking at two of them: the marking out tools and the measuring tools. For marking out tools basically are the instrument used to mark or make lines on metal surfaces. You want to draw some line on the metal surfaces, or you want to make alignment, you need this marking out tools to do that. They are very fundamental in accurate fabrication and assembly. All right. So we shall be considering some of them. The first marking out tool we like to consider is the surface plate and the surface table. The surface plate is actually a precision flat surface, as you can see here, for placing workpieces during marking out. So is a surface where you keep your object that you want to mark, all right? And it's also used for testing the flatness of surface. So that is a surface plate. And when you I don't know when you're not using surface plate, it is better to cover it after use so that it doesn't get damaged or get scratched. So the other related one to it is known as the surface table. It does similar work with surface plate. It's just that it is larger than surface plate. Look at it here. It's a table. It's form of a table. It is designed for bigger workpiece. If your workpiece is a bigger one, the surface plate might not be enough. So you need a bigger surface. So and that's called surface table to do your work. Most of the time, it is cast iron construction that take place here. Okay, if you want to mark out anything, these are the surfaces that you place your metals. Okay, so I will say that let's now consider other marking tools, marking out tools. We have what we call the scribers, the dividers, and the punches. Okay, this is these are punches, this is a divider, and this is a scriber. So the scriber, like you could see here, look like a pencil. So the metal worker's pencil is what we see the scribers are. So it just basically does the work of the pencil, as you can see, but in this case for marking out. So it's made up of high carbon steel, okay, used for marking out lines using your hand. Okay, we are looking at the hand tool this time around, not machine tool. So we use the scriber for marking out lines. And on the other hand, the divider is a two-legged steel. As you can see, it has two legs for scribing arcs, curves, and setting off distance. If you want to mark curves, if you want to mark arcs, okay, you will need the divider to do that. Okay, so it comes in different form. It can come in a spring-loaded form or in a firmly joined form. Look at this one. This is a firmly joined form. The other one that come in form of spring, so that the leg can be flexible. All right. So having talked about the divider, we also have what we call the punch. The punch has different type, but what the point does is for making dents. Okay, you want to make some point or dents on your metal surface, you make use of the point. So we have the dot punch if you are interested in creating dents along scribed lines at intervals. Okay, so if you want to make dent in form of 60 degree, so you make use of the dot punch. But if you want to make dent with the end point of 90 degree, you make it of the center punch. Okay, this is dot punch here. So the mouth is having 60 degree 60-degree conical end, while for the center point, the mouth is having 90-degree conical end. So by the time you use it to mark the metal surface, you will get that particular angle. So these are the other marking out tools that we have. So we also have other ones too, like the tri-square and the box square. Okay, this is a tri-square here. The tri-square is for testing surface squareness. We want to be sure that the surface have a perfect square, and we also use the tri-square in marking out angle 90 degree, as you can see here. So you need to mark out angle 90 degree. Please, you have to handle this hand tool with care because you can easily get damaged too. On the other hand, we have the box square. While the tri-square is used for marking out 90 degree, the box square is used for marking out parallel lines on round or bars. You can see, so you can easily mark two parallel lines, okay, because of the way it is designed. Sometimes it has graduation so that you can get dimension. And when it has graduation, that means it's performing dual function. That means it's doing the work of marking out truths as well as measuring truth. But basically, they do not have graduation on them. When I say that graduation, I mean those divisions that you see on rulers. Okay, all right. So that is the tri-square and the box square and their functions. So I won't say that. Can we proceed to the measuring tools now? We've been able to see the marking out tools and the work they do. Now the measuring tools help us to determine length, width, thicknesses, and sizes of metals. Okay. Measurement occurs during marking out to ensure precision and accuracy in fabrication. Okay, so it is not enough for you to just bring out your measuring tool. So the first stage is to mark out like we have considered earlier. Then after marking out where you want to measure, then you bring out your measuring tools to measure what you have marked out. So marking out takes place before measurement. All right. So, but some other time it can be reversed too. Now let's consider some of these measuring tools. Okay. Firstly, we are going to look at the steel rules and the calipers. The steel rule is just like your normal ruler of 10 centimeter, 15 centimeter, 30 centimeter, and so on and so forth. The only thing is that it's made up of steel. You know, we have rulers that are made up of plastic and rubber, but in metal work, we don't make use of those kind of ruler. We prefer that it's made up of steel because it's metal work we are dealing with. So this is a steel rule. So it's made up of steel, stainless steel, and it has this graduation for measurement. Okay, it is graduated in millimeters and centimeters. Okay, so you place it on the edge of the object you want to measure to get your reading. So aside from your steel rule, we have what we call the internal caliper. The work of the internal caliper is to measure diameters, weight, and thicknesses from inside surface object. Okay, this is an example of internal caliper. Maybe you want to measure, look at this container now, you want to measure the internal diameter of this container. The best instrument to use is this internal caliper. All you just need to do is to insert the legs of the internal caliper and then stretch it. By the time you stretch it, then you'll be able to get the measurement. You place these two legs on your steel rule and get the measurement you want. Okay, so that's what the internal caliper does. Is used for measuring inside surface of objects that are difficult to measure with other tools. So we have the opposite of the internal caliper, known as the external caliper. The external caliper does the opposite work of the internal caliper. It measures diameters, width, and thickness from outside surface object. Like you can see, this is a typical diagram of an external caliper here. See the object there. Maybe you want to measure the external diameter of this cylindrical object. You just place the two legs of the external caliper there, and by the time you do that, then you take the length into your ruler to get the exact value. So lastly, we have the odd leg caliper. The odd leg caliper measures from center of object to outside surfaces. It's useful for offset measurement. This is it here. This is the odd leg caliper. So usually we use it for measuring center of object to outside. If you want to get the center of an object, the best tool is to make use of the odd leg caliper. Okay, so it has other name, and we have said that in our previous classes. So I will leave it. I will leave that to you to find out in the previous lessons. Okay. Now, having said that, so we can now consider more of the measuring tools, and the next one is the combination set and the precision instrument. For the combination set tool, look at it here. It's called combination set because it consists of three instruments in one. Okay, it's three head measuring instruments that have with center square. This is center square here, and it has square head of 90 degrees. This is it here, and also protractor of 0 to 1. This is it here. So basically, you use it, based on the instrument there for the protractor part for measuring angle, for the square part for measuring angle, for measuring parallel lines and sometimes angle 90 degree, and of course for the center square you use it to measure either length or angle 90 degree. So it's called combination set because of the combination of the three instruments on it. Well, that's not enough. We have other instruments. We call those one precision instrument because they allow you to get precisely the length, the measurement you want to get. They give you the exact measurement that you're looking for, and they measure very, very small length. That's why they are known as precision instrument. And one of the precision instruments is known as the micrometer. The micrometer has different type, okay, for measuring smaller objects, and usually it is calculated in millimeters because it measures small objects. So the micrometer come in two forms, either internal or the external. And there is one major one that combines these two. It's called the micrometer screw gauge. Okay, this is it here. The micrometer screw gauge. So the micrometer screw gauge can measure the external part of an object. Look at it here. So this space here is where you keep the object, and then you screw it. This can be screwed. You screw it until the object is being held by the jaws, and then you can now take your measurement. Okay. Now, aside from the micrometer, we have the vernier caliper. The vernier caliper too is in two forms rather. We have the external and the internal part. But there is one uh, that carry the two side of measurement, and this is it here. So the upper part, the upper jaw here is used for measuring the internal part of an object. Maybe you want to get the internal diameter of a cylinder. You can use the upper side of this vernier caliper. And if you want to get the external diameter, you can use the lower jaw of this caliper. And this part here is where you can take your measurement after it's being used. So there are one or two instructions that you need to follow to know how to get the exact reading. So aside from the vernier caliper, we also have what we call the depth gauge. Of course, based on the name, the depth gauge is used for measuring the depth of holes. Okay, if you want to measure how deep a hole is, you use the depth gauge. All you need to do is to insert the depth gauge inside the hole, and you get the measurement. Okay, like it is similar to the micrometer. Okay, that we mentioned earlier here. And then the opposite is the height gauge. The height gauge is a tool, is a hand tool to determine the height of an object, and it's also used for marking out the dimensions. So it has dual function. It serves as marking out tool as well as measuring tool. All right. So having said all of these, both for marking out tools and measuring tools, let's now look at the tool selection guide. Maybe you want to work in a workshop with tools. Let's look at this guide. So the two category, when you have surface plate in the workshop, as a reminder, the surface plate is for marking foundation. So it's the surface where you mark out objects. So, and if you have scriber or divider, we use it for line marking. You want to mark lines. If you want to make points on the object, indelible point that will not be cleaned easily, you make it of the punches, and we mentioned that there are different type of punches, but we only cited two examples: the dot and the center point. And then if you want to mark an angle on the metal, you make use of the tri square or the box square. All right. If you want to measure the length of a metal, you make it of the steel rule. If you want to measure the diameter or thickness of an object, make it of the caliper. If you want to get the exact measurement of an object, if the length is very small, make it of the micrometer and or the vernier caliper. Either of them serve purpose. But if you want to get you want to get precise internal diameter, the best instrument that works is the vernier caliper. The micrometer does more of external diameter, but it measures smaller length than that of vernier caliper. So that's the difference between the vernier caliper and the micrometer. Okay, so we have been able to see the importance of both the marking out tools and the measuring tools. They are the foundation of metal working excellence. Proper tool selection, care, and techniques ensure accurate fabrication, assembly, and quality result in every project. So you need to master how to use this tool so that your project is a perfect one. Yeah, so we shall be doing the cutting here today. I hope you have learned something. Thank you for watching and have a good day. Bye for now.